What's up, everyone? My name is Jeff, and welcome to my channel, where today we're going to look at 5 ways to feel more comfortable about using Git. You just got to create a branch and get on with it. Fair warning, nothing you hear on this channel is going to really be truly universal, so if you don't struggle with keeping your code under control, a lot of this stuff might not be for you, and that's okay. Keep doing what you're doing. Now, today's video is going to be focused on Git, which is a version control system. Now, Git is everywhere in the world of open source software development and also very, very common in in-house proprietary software projects. And with websites like GitHub and GitLab, Git is just everywhere. So today, you're not going to get a tutorial on Git. So I'm assuming that you're already using Git and have been frustrated by it in various ways. And we're going to look at reducing that frustration. Let me know down in the comments below if you would like to see another Git tutorial, or if you have a favorite one you like to share it with others. So without further ado, let's dive in. Tip number 1, use a tree viewer. Now, when I say tree viewer, I mean use a program which will display your repository's history tree in a visual way. Now, there's nothing wrong with using the command line, and for many things, even in my personal Git workflow, I use the command line with great success. But I think there's a lot of value in keeping your mental model in sync with your repository as you're working it, and seeing your tree history visually helps tremendously. Now, there are a ton of GUI tools out in the wild. I'll leave a link down below in the description to a page containing a nice curated list of Git UI tools. No matter which tool you use, generally a tree viewer is going to give you a visual representation of your local branches in the current branch that you're on locally, your remote branches, where they are, your individual commit diffs, like what each commit represents, diffs between branches, or diffs just between any 2 commits, and being able to see your commits sorted, which is typically done by commit date. So in addition to these things, a visual representation of your history also can help you with some simple operations, some of which aren't actually simple, but they seem simple when you have a tool to help you out with it. Could be with creating new branches on arbitrary commits, not even just creating a branch on the commit you're on currently, but also just go create a branch on any arbitrary commit. Cherry picking is really easy to do in a tree viewer. You can just click a commit, say cherry pick it into the local branch I have checked out. Or you can do branch resets to another commit somewhere. Now, I typically do hard resets, and Git reset can be scary, but it doesn't have to be. Your tree viewer will help you know exactly what you're doing, and stay tuned because we're going to look at later on how branches can help us not be scared of things like that. So what tool would I actually recommend you use, right? Well, the real answer is the one that you like the most. You know, like I said at the beginning of this video, there isn't really a whole lot of universal objective, this is the best one. A lot of these choices come down to taste and preferences. And so that said, I will share which one I use, which is called GitK. I've been using it for almost a decade now, and it has everything I could possibly need in a tree viewer. So I think the best way to show you this is to demonstrate it. Let's go over and look at some code. So as a quick example, I wanted to show a project I have up on GitHub called tsymd, which is a little C++ SIMD library I wrote a while ago. And the details of that doesn't matter because we're just going to look at its Git repository. And I have it cloned here locally. So to bring up GitK, you just run GitK from the directory of the repository. And instantly you see all kinds of useful information. We can see the branch we have checked out. We can see the remote associated with it, where it's at, which they're in the same place right now. We can see commits themselves. So they're the tagline, first line of the commit message is what shows up here. And we can click any of them and view more details, like if there was more commit message there, the diffs in each file, all kinds of metadata about the commit itself. We can come over here and see what are the files that changed in this commit. Well, there was a bigger one. And you can see all these different files that changed in this commit. But what's really neat is you can also come over here to tree and see what was the state of the repository at this commit. So after this commit's applied to the repo up to this point, this is what the contents of the repository would be. And then there's other things you can view the author, so I can say, oh, here my colleague Tim Rowley, he made a commit. Look at what he changed. We can go also see other things like where merges happen. So there are some places where someone branched off and made a couple commits, and then someone else made a couple of commits, and then we decided to merge them together here. This is all very easy to see visually and easy to kind of keep under control of, hey, what's going on, but this is actually not everything. So if we close this and then decide to run git k -- all, we can actually see all of the branches that are on this repository. So we still have the local one we have checked out, main, and the remote, but there are other remote branches that are on GitHub that I don't have locally checked out here, but they then show up with -- all. We can see even in time that, these aren't super old. We have a feature branch I worked on a little bit that kind of stalled out working on it, but that branched off at an older place. Have some other older branches, but the point being, this is my normal view with git k, is to just always view everything, knowing that my local checked out branch will be where the view initially is. So if I were to like create a branch here, which look how fast that was to create a branch on that commit. Yeah, it's not even checked out. We can just create branches wherever we want, but if I were to then check that out, and let's say that's what I was working on, and I did git k -- all, it's nice that it initializes the view to where I'm at. So even if, we got a bunch of commits coming from the server or something above, it's not going to disrupt my local view, even if I run -- all with git k. But we can check out main again. We can remove this branch. There's just so many cool things you can do. We can actually have if we wanted to say, hey, what's the difference, the entire difference between the repository state on this commit and this commit? And so we can actually do that by taking a commit, selecting it, and then right-clicking and diffing with another commit. We can look at what is the entire diff between those two. So they could be wildly different. So we could even say, like, what's the diff between these two wildly different states? And yes, lots has changed since that commit I randomly chose. But it's a really helpful tool to see if someone has quite a few commits and then someone else has quite a few commits. You can diff across those without having to keep in your head all of the summed up changes for all of those different commits. And then there's really cool things like cherry pick, which is a fun little operation where if I have, let's say, like maybe main is a branch that I don't want to directly commit to. So let's say I wanted to create a feature branch, JDA feature, because this is just an example. And we had that checked out. I could actually cherry pick this by just right-clicking on it and cherry pick this commit. And there you go. Now JDA feature has this commit in it, but it's on top of main. So based on what I just did, it's the equivalent of rebasing this onto main. But the point being is I just wanted to cherry pick a commit, and that was trivial to do, to just point, click, and cherry pick. So that's super helpful. You can also do reverts. So I could say like, I have no idea if this is going to cause conflicts, but let's just say I wanted to revert this commit. And of course that has conflicts. Well, this is a cool way to demonstrate resets. So if you're familiar with resets, you can trivially do that. I just want to reset this branch to here. Update README. We'll say, here we go, this one. We can revert this commit. And there you go. We now have a commit that is the inverse of the commit that we wanted to revert. And all of this was trivial to do from git k. A tree viewer should help you accelerate these workflows, so you don't have to keep a mental model of this structure, and I'm cherry picking this SHA ID, and I'm making sure that, like, don't go crazy with that in your head. Just let your eyeballs do most of the work for you. Tip number 2, build your commits visually. Now this is very, very similar to tip number 1, but this covers everything else that your tree viewer can't do. Some GUI tools for Git combine a tree viewer with the ability to build commits visually. So depending on the tool that you would pick to view your Git commit history tree, it might be the same one that you use to build your commits. Now, there are some of the same caveats with tools to help you build commits as there are with tree viewers. It boils down to taste. But fundamentally, the things that you would use to help build commits are going to be seeing what files are unstaged or even untracked in your local repository. You want to stage entire files or stage individual lines of a file. All of those things, but in reverse. So unstaging lines or entire files. You could want to just revert entire files or even revert individual lines to their previous state. Or you can amend the previous commit instead of creating a new commit. I think the biggest thing that a UI helps with here is not accidentally committing stuff. Now, because the command line makes it somewhat more difficult to browse your local changes and look at all of those things that were just mentioned, there's this desire to just lean on git commit -a. Ugh. Now, this blindly takes every file that's tracked in your repository that has changes, and it stages and commits it all in one go. And this typically has two very common pitfalls. First, that untracked files that need added explicitly are omitted, and that there's no review process for what should be staged. And so both of these things are things that the command line has answers for. You can do it. The issue is not, can you do it? The issue is it helpful? Or is it doing you a favor to have to go hunt those things down on the command line? And I think a UI makes this a lot easier to reason about and to use correctly. My favorite tool that I've also been using for nearly a decade is Git GUI. So just like with Git-K, let's have a look to see it running live. So just like with Git-K, we're going to use tsymd as a repository example for Git GUI. Now, just like Git-K, we can run Git GUI from inside the repository. And because we have no local changes, there isn't much to see. So to do something, we're going to pop over here to VS Code that I have already opened to my local clone of the repository. And let's say, let's make a change. So I have an option to, if you want to, even though this is a header-only library, I have a test set of tests that you can build if you wanted to build this repo locally. And let's just say, hey, I want to actually have that be on by default. And why not? Let's just build everything by default, because why not? And okay, so those are my changes. It's a 2-line change, so I can run git GUI now on tsymd and see, okay, now I've got all kinds of things to look at. One is what's unstaged. This means these are changes to my local repository that I've not put in the staged area yet, and this is the diff of what this is. Now, what I can do is just straight up stage the file. Great, cool, that stages the whole file. I can also unstage it. But what's really cool about this tool, and a lot of other Git UIs can let you do this, is I can actually highlight a subset of lines, right-click and say Stage Lines. So that means actually I have only staged a subset of this file, which is, of course, possible on the command line because these tools all boil down to making Git calls in the end. But man, it's so easy to just highlight and say, hey, I want to stage this. Or if I close this, I come back and I made changes somewhere else, like, oh, let's say we needed CMake 3.5 instead of 3.2. So I run Git GUI. I've got what we call a hunk here, and then a hunk here that you can see. These are identified by these dividers, these at dividers, and I can actually stage a whole hunk. So that might make more sense on this lower one. Stage a whole hunk, which is like the same as staging all of the lines. But at the end of the day, like this makes it very quick to go through. If I have a lot of files that have changed, I can go through and audit exactly what are the pieces of these local changes that I want to put in my staged area. And then I've got some other things too. I could, come up with a commit message, of course, like build tests and benchmarks by default. Great, cool. Now I can go ahead and commit that. That's fine. Also, what you can do is I can click in Git GUI, you can click this button, which is to amend the last commit. So wherever I'm at locally in the repository, if you hit the amend button, I can actually go and I could basically create a commit and then, oh, but I forgot a few things. So let's do this. Let's go crazy. Let's say I stage this and that was my commit. And then later we did the change to the CMake minimum required. And let's say I wanted that to be a part of my previous commit. Well, I can hit amend and then say, oh, but I want that to also be change CMake minimum requirement. I can go ahead and stage that, and now that's my commit. And if you haven't pushed, then you can amend and do all kinds of changes, build up your commits, amend them, modify them locally, and then push them later. So if we run git k, we can see I did commit this straight to the main branch, which I would probably want to use a feature branch. But the point being is, here's the commit. It actually also shows that I haven't pushed main to the remote yet, because my remote origin main version of the branch is here and my local one is here. And so, yeah, using Git GUI to build that commit, I can also do interesting things like if I were to go back and let's say, oh, I want to stage this, but I don't want to change my CMake minimum required. You know, I could make this commit. I don't have to commit first before I do what I do, but I'll like say, okay, I want that to be a commit. Then I can go here and I can go to commit and say revert changes. And so what this is going to do is basically just blow away this and go back to the original state, which is really handy. And I can actually show you a really cool thing as well. So if I were to do 3.5, if we go back to making this all part of this commit, what I can actually do here is I could say I want to stage this hunk and then revert this, and I didn't even have to commit. You know, this tool is very helpful to just speed up building commits and doing quick amends. There's some convenience buttons there, but generally I've shown you most of what I use is staging and unstaging, viewing diffs, staging and unstaging individual lines, forming commit messages, doing things like amends or reverts. There's all kinds of useful things that this helps speed up. Tip number 3, use branches to save temporary changes. Now, branching in Git is free. Now, what I mean is that when you create a branch, it's so lightweight, you shouldn't even think about it. I like to think of branches as sticky notes on your tree of commits. And so your local branches are sticky notes that you control, and remote branches are sticky notes that some remote repository is controlling, and then we'll use ways to keep those in sync. Like, for instance, this explains how git push might work. Git push will say I have my local sticky note here with these commits, and I want to have the sticky note that's on the remote repository be at the same place. And so that's what git push does. It says my local sticky note, and make sure that the remote is in the same place, which is interesting because people sometimes will think git push only is about adding commits, but you can actually push and move branches backwards in history if you made a mistake. Please don't regularly do that. But all of that said, if you just think of it as like sticky notes on a tree of commits, then it's easy to think about just what push is doing and in fetch, etc. Now, git commits are generally viewable and reachable if there's a branch that contains those commits. So it doesn't matter if it's a local branch or a remote branch. It only matters that there is some branch that has those commits behind it. So technically commits are always in existence. They're always in your repo until you prune them away with something like git prune. So can you go find commits that are orphaned and don't have a branch associated with them? Yes. Please do not rely on this if you want to stay sane. So how do we use branches to help us out here? Let's look at some examples. So for this next example, we're back with tsymd, and we can run git k and see where we're at. Now, I went ahead and checked out this deunionize pack branch because that was the feature I was working on a long time ago. And I've decided, hey, I would like to do a rebase to make sure I can get all of these commits, all 4 of these commits. I want them on top of the main branch. And sometimes rebases can be scary. You can get yourself a little twisted around merge conflicts and like what's going on, and it can be a little scary and intimidating if you're not comfortable with doing rebases. So one thing you can do to give yourself some peace of mind is just use a branch. So if we check out a branch, let's just call it temp, because it really doesn't matter what the branch name is. No matter what I do with this deunionize pack branch, temp will always be here and basically pinning these commits to this location. So there will always be this state to fall back on if I screw up this branch in the rebase. So let's go ahead and try this. So git rebase origin main. And then, oh no, we have conflicts. Now, if I run git GUI, they're not that bad. I tried this just before turning the camera on, and this isn't that bad. So let's just think here, though, that this rebase went way worse, and this was a million different conflicts, and you tried to fix some of them, and it didn't really work, and who knows what's going on. At the end of the day, if we do git rebase, can I now? I gotta actually let's actually do something really bad, and let's go ahead and stage conflicts in the repo. Please never do this. But the point is we need to make a mistake to then go back to the original state. And so need to git rebase continue. Okay. So, this is actually continuing to go worse. Maybe I should have followed this a little bit more. Let's just keep making this awful. Let's make this the worst rebase in the world, and just keep making it worse. Oh man, this is bad. Oh yeah, so many conflicts. And if we keep going, okay. Now if we run git k. So if you've seen, I have an alias for git GUI is GG, and git k all is an alias for git k -- all. So my muscle memory is kicking in there, but that's what I'm doing. So I got these terrible, terrible commits. There's one here. Yeah, like we actually committed the conflict markers, which is just, please never do that. Okay, so oh no, this got messed up. And let's say that this deunionized pack didn't even have a state on the remote. And this is how we can really make some fun here. So if we get push origin deunionize pack, I just deleted, this will delete it off the server. Okay, so deunionize pack no longer is on the server. So I don't even have that to rely on. And I'm just looking at this like, goodness gracious, what has happened? Because this is we screwed this up. This is the beauty of having this local branch here. See, these commits are not gone. They're still here because we created this little temporary branch. So there's a couple of things. One is if we just wanted to say, hey, let's take deunionize pack and stick it back on this commit, which is the original state it was in, we can just do a hard reset. That's it. You know, that rebase, it just kind of got recanceled, and we just reverted back to its original state. Now I'm going to go ahead and bring things back to the way they were. Push origin deunionize pack. And I do this all of the time, where I'll actually do something like a rebase or whatever, and it goes really poorly. And you know, before we actually created a local branch, and if you ever have any doubts of what to do, just create a local branch. It's fine. But what's cool is these remotes only get updated when you push to them or if you fetch. So you're the one that decides when your remotes get updated, even if you're talking about branch refs that are from someone else, that they updated the server, that the remote branches, you know, are always going to be there, and you can't, unless it's through fetch or or push, these aren't going to change. So we can do all the stuff we just did with that git like I could just reset my local deunionize pack here. This origin ref is still going to be here. So if I close git k and I come back and there it is. I have not done fetch or anything. So that's another layer of help if you don't want to like pollute your local branch list with tons of temporary branches, which is fine. You can use your remotes almost the same as a temporary local branch. Just know that if you fetch, those remotes might change. So having local branches will defend you even from that, because I could do like a local branch here, and someone took this branch on the server and pushed all kinds of changes to it. It's not going to change my local temporary branch or my local deunionize pack by just doing a fetch. So give yourself a couple layers of comfort in using branches to give you a place to go back to in case things go wrong. Tip number 4, have a branching strategy. Now this tip is a little bit more philosophical, as there's many good branching strategies out there. The point here is that I think it's a good idea to control the complexity of the project you're working with, to be thoughtful with how you're going to treat your branches in your repository and give them roles and purposes and have rules. And we'll talk about some of the details of what those might be. Some things that you might want to look out for in your branching strategy would be, what does the default branch in your repo represent? Do you prefer straight line history? Do you prefer always having merge commits when you take 2 branches and merge them together? Or do you use a combination of both of those? What does a branch mean? Like if I have a feature branch, a release, or whatever it is, just what does your branch mean that isn't your default branch? Are any branches special or protected? So are all branches force pushable? Are no branches force pushable? Are there some branches that are protected from that and some that are not? And then finally, do you use git tags? And if so, what do they represent? Now, if you don't know what a tag is, think of a tag as a branch that is not expected to change. Technically, you can delete them and repush them, but a branch implies it will be progressing in time. And a tag just says, we're going to mark this one. So if you're working by yourself, and you don't have multiple topics of development and you're just kind of working on a project straight line, it's entirely possible that everything that was just asked that you should be asking yourself about what your branches mean, it could all just be your default branch. It doesn't have to be complicated. On the other hand, it can take as little as one other person working on your project to cause headaches unless you agree upon some type of plan for how branching should be approached. And sometimes you can just make a mess on your own if you have multiple thought processes of development. You want to work on something, and then on something else independently and not have them be merged together. You can do that yourself. You don't even need other people. But fundamentally, it all comes down to your needs. Just like pretty much all programming tools out there you use, Git will not think for you when it comes to how you should use it. Instead, you should be thoughtful with how you come up with your own rules and guidelines that help control your usage of the repo in some expected way. Git's a powerful tool. It's got a lot of features and supports lots of different workflows. So I guess this could be rephrased as pick your workflow that works for you. So for this last example, we're going to use a project that I've been working on at Intel for many, many years called Osprey. It's a ray tracing library, and it's got a bunch of commits in it. It's big history. So we're going to talk about our branching strategy for us to stay coordinated as a team about how we treat special branches and feature branches and merges and all of that. So if we run git k, so I just took a fresh clone of Osprey off GitHub, and if you did that today, when I'm recording this, this is what it would look like. We have our main branch, which points to our latest release, and you'll see there's a couple of different branches that we have. So our main master branch here refers to our latest release. And all of our releases are also tagged. So if we go back in time and start going back in history, every time you see one of those yellow tags, that's a release that we made. So we always know exactly what is the state of every release we've ever done. You'll also see that there's a branch called devel, which is our upstream branch for whatever's going to be our next minor or major version. So major version doesn't happen very often. Minor versions happen more frequently, a couple times a year, ideally, where those are going to be new features, things that are new, that are introduced in the library. That's what Devel represents. We do have patch releases occasionally, and what that usually represents is the feature set that are in the major minor combination. There were some bugs that we fixed, so we don't put features in that, but that's the way we do our versioning from a version number perspective. It's typically called semantic versioning. But as it relates to branches, Devel represents things that we have, features that we've implemented that we consider done or ready to go. And we have an internal clone of Osprey that we develop with and then sync it here to GitHub. So these are all the commits that we've worked on as a team, but Devel this is going to turn into, will probably be version 2.3 as of right now. And then the last type of branch that you'll see is release dash and then a major minor .x. And what that is all patch releases related to a major minor combination. So for the 2.1 series, we had 2.1.0 and a 2.1.1. And so the release branch referred to all of the patches associated. Like this one would be all the 2.0s that we did. This would be the latest of the 2.0s. So if you ever wanted to track a particular major minor version but wanted the latest patch release, you could use a fixed branch name to track that. And we've been doing that for a long time. We go really far back in time. We can see we had 1.1.x, and that was, obviously right before the 1.1.2 release. And if we go back, we'll find a 1.1.1, and yeah, like this branching strategy has been fantastic, because what we do is basically there's a few of us that work on patches. Usually we only end up patching the current release, and then once we go to the next minor or major version, we just start working from there. And basically all features that people are working on for the next release are just going to always dump into Devel. And then, branches that are on top of Devel are just in progress work. And so it's a great workflow to make sure that master, you'll notice that it only gets merges from release branches into it. So that we always know that master, all the commits, merge commits with master come from releases. All release branches always come only from Devel. So we will branch off to make a release, finish final release things, patch stuff, and then that gets merged into master. Then we take master and put it back in Devel, because people might have been implementing features in Devel, so we want to make sure everything's still in sync there. But the point is like, as long as your feature branch is on top of Devel, it kind of doesn't matter where else it is, what everything else in the tree is, because no one pushes to master directly. People don't, we don't have anyone pushing to release branches directly. We're always doing feature merges into those, which brings up another point, which is we use a combination of merge commits and rebases. So you'll notice this is a big, long line of commits, and they have different authors. So like these commits from Sebastian were probably on a feature branch implementing what he wanted to implement. And those commits were rebased on Devel at the time, because Devel would have been about here, and then this was a feature branch that got merged, and that was a fast forward merge. So we try to make things as straight as possible for straight up features, and then when it comes time to do releases, we always do a merge commit. So then that's useful when we look at our main branch. We can just very quickly narrow down just the release merges that happen. So it's easy to identify those. So again, it's not necessarily the universal way to branch your project, but we found, at least for us on the Osprey project, that this has done a good job at keeping us coordinated with what branches mean what, and who updates them, and when do they get updated, and where do new features go, and what process look like. That it's really helped us stay coordinated as a team to collectively work better together. Tip number 5 you should prefer git fetch over git pull. Now, this tip is going to sound controversial, and to some it really is. If you've never been surprised by doing a git pull because you know exactly what you're doing, and that's great. Keep on pulling. For the rest of us, git pull can be surprising because it's fundamentally doing two things at the same time. It's doing a git fetch, which git fetch will bring down updates from your remote, and then immediately followed by a git merge, which is going to take your branch that you're pulling, and it's going to automatically merge with what the remote state is. What I've seen consistently in my career is that the merge phase is usually what trips people up the most. Now, why is this? The changes that were fetched from the remote were surprising, and may need careful consideration before acting on those changes, like to do a local merge or rebase or something else. So to stay as frustration-free as possible, I've personally adopted a workflow where I always just do a git fetch to update my remote branches that are in my local repository. Now what this does is it lets me see what changed on the server and then decide what am I going to do. And sometimes this can be really diverse in what ends up happening based on what changed. It could be I do a hard reset to whatever the remote state is. It could be that I do a rebase on a remote branch, like a feature branch I'm working on that I want to rebase on, like whatever the latest release is. I might do that as a rebase and not a merge. I might also step back and see, wow, things have changed so dramatically. I need to rethink about, do these commits even matter, or should I somehow make these changes and re-implement them, or choose a different method for how I'm going to approach applying those changes to the latest value of the state. And so for some of those, git pull can be configured to do some of that stuff, especially like the rebase option. But I just want to point out it doesn't make it inherently easier. I found that a simple git fetch followed by opening gitk and seeing what to do, it's been a very, very robust way to never be surprised when I'm getting changes from a remote server. So that's it, folks. I hope these tips help you find Git to be a tool that you can wield to your advantage as you work on your code instead of getting in the way, so that you can feel better about the problem you are working on, which is the project you're coding. Now, if you've enjoyed today's video, consider liking this video and subscribing to the channel. And until next time, happy coding, everyone.